Welcome. All right, so in this example, again, we first want to determine the end behavior. So we know that our exponent is odd and our leading coefficient is positive. So therefore, our graph is going to fall left and rise right. The next thing we need to do is determine the zeros. So I'll set my function equal to 0 and say x cubed plus 8x squared plus 16x. Now to solve for x, what I need to do is factor out the x, because I see that every single term factors out the x. So I have 0 equals x times x squared plus 8x plus 16. Now I want to see, can I factor this down a little bit further? And I know that this is now a factored form. This is a perfect square trinomial, which can be factored down to a binomial squared, which is x times x plus 4 squared. Now I can apply the zero product property and say that x equals 0 or x plus 4 squared equals 0. So now I already know that x equals 0 is a 0. And then to solve this, I can use my square root method and say x plus 4 equals 0. By subtracting the 4 on both sides, x equals negative 4. Now the next thing I want to do is go back and look at the factors and make sure and look at the degree of those factors to determine what the multiplicity is going to be. Well, I could rewrite this as x minus 0 if I wanted to, or x plus 0. It doesn't really matter. But I noticed that the exponent is going to be 1. So therefore, the multiplicity of this is going to be 1. But here I have an exponent of 2, so the multiplicity of this 0 is going to be 2. When the multiplicity is odd, we know that the graph crosses. And when we have even multiplicity, we know that the graph is going to touch at that point and then rebound. So there you go, ladies and gentlemen. That's how you find the end behavior, zeros, and multiplicity. Thanks.